Welcome to Daily AI Brief. Today, we're diving into groundbreaking advancements that are reshaping the AI landscape. From new AI models tackling local workflows to the emergence of observability platforms for large language models, we're covering the innovations making waves in 2026. Meta recently introduced Muse Glimmer, a 30 billion parameter model aimed squarely at improving local AI workflows. This dense model balances the demands of multi-step tasks with the need for privacy, allowing data processing directly on the user's hardware instead of utilizing distant servers. What's significant about Muse Glimmer? It focuses on handling extensive context, making it suitable for tasks involving complex software management and documentation. The model's ability to process locally significantly alleviates data privacy concerns, as sensitive information remains on site. Technically, Muse Glimmer harnesses a dense model architecture boosted by 30 billion parameters. This ensures high throughput while maintaining low latency, with operations optimized for rapid local processing. The API is designed to blend seamlessly with current workflows, supporting multi-step task execution at less than 100 milliseconds of average latency per task, which equates to the kind of near instantaneous response times critical in time-sensitive applications. Benchmarking results show Muse Glimmer's performance to be competitive. Its throughput capabilities are reputed to be on par with established models such as Opus 4.6 and Gemini 3.1 Pro, although these findings are preliminary and subject to further evaluation. These benchmarks emphasize not only the model's efficiency, but also its practical application in real-world scenarios where high performance is essential. While Muse Glimmer's local focus enhances privacy and performance, this shift also raises concerns about reduced community input. Transitioning from open-source models like Llama to proprietary systems such as Muse, Glimmer might stifle innovation by limiting collaborative opportunities, posing a risk to not just Meta's open-source contributions, but also to the broader AI community that thrives on shared development efforts. Curious about trying Muse Glimmer? Check out Meta's API documentation. The model supports local workflow implementation with detailed instructions that facilitate integration. Demos are available, offering practical insights into configuring multi-step tasks, which is particularly beneficial for developers focusing on complex, layered operations. Meta's move towards proprietary models is bold, potentially setting a precedent in AI monetization and control. It raises the question, will the community embrace or shun this type of evolution? As the AI landscape shifts, the outcome of Meta's strategic direction could significantly impact the future of collaborative AI development, influencing how major tech companies balance proprietary interests with community-driven innovation. NVIDIA has launched the NemotronLabs VoiceChat 11B, a state-of-the-art speech-to-speech model that redefines real-time conversation capabilities with its sophisticated full-duplex architecture. By seamlessly integrating automatic speech recognition, ASR, a large language model, LLM, and text-to-speech, TTS functionalities, this model significantly enhances natural dialogue interactions. At the core of VoiceChat 11B's innovation is its ability to manage conversations with extraordinarily low latency. The system achieves this through a 450 millisecond turn-taking latency, ensuring sub-second response times, which are critical for dynamic, interruptible interactions. This ultra-fast processing is driven by the Fast Conformer module, specializing in high-efficiency audio encoding, and further refined by the Nemotron Nano V2 9B backbone that optimizes language comprehension and generation. These components work in tandem to eliminate the traditional need for multi-model orchestration seen in most current AI solutions, where separate models for ASR, LLM, and TTS often introduce additional latency and complexity. By consolidating these tasks, NVIDIA's unified architecture not only enhances speed, but also reduces computational overhead, thus making the system more efficient for deployment on NVIDIA GPUs. Despite its promise, the VoiceChat 11B is currently in early access, having launched in March 2026, with general availability yet to be announced. This phase allows developers and companies such as Accenture, Microsoft, and Deloitte to integrate and test its capabilities, ensuring the model's robustness in real-world enterprise environments. However, performance metrics have not been fully disclosed, leaving some uncertainty in its operational effectiveness compared to existing solutions. There are also considerations regarding integration challenges with existing systems, necessitating a flexible approach to deployment. For those interested in leveraging this powerful tool, access through NVIDIA's developer portal offers the first step. From there, developers can utilize reference deployment containers available on GitHub, providing a ready-made infrastructure for initial experimentation and testing. Additionally, guided fine-tuning paths for domain-specific applications help customize the model for specialized needs. NVIDIA's foray into unified voice AI with the NemotronLabs VoiceChat 11B not only improves efficiency and response times, but also sets a new benchmark for interactive communication technologies. This development could greatly influence customer service, elevate virtual assistant capabilities, and streamline enterprise communication, thereby setting a potential new standard in AI-driven interactions. ByteDance's SeedRealtime is setting new standards in multimodal interactions with its groundbreaking, real-time, full duplex capabilities. It's specifically designed to handle audio and visual inputs simultaneously, significantly bolstering user engagement in a wide array of fields, including gaming, live streaming, and virtual meetings. SeedRealtime leverages a unified architecture for processing both audio and visual content, allowing for smoother and more immediate interactions. This is achieved through advanced algorithms that ensure synchronization between audio-visual outputs, minimizing latency and thus boosting responsiveness. The integration of these capabilities into one model facilitates seamless back-and-forth communication, where the system can listen, watch, and speak all at once. While precise latency metrics have not been detailed publicly, ByteDance claims SeedRealtime outperforms its predecessors by reducing processing delays. This includes abilities such as processing multiple concurrent input streams, which significantly enhances throughput and ensures a more efficient user experience. These improvements facilitate applications that require intensive and rapid data handling, enhancing content creation, interactive media, and real-time user feedback. Potential scaling challenges could present themselves as user demand increases. The system may need further optimization to handle broader adoption without compromising on performance. Additionally, concerns over voice cloning accuracy and privacy represent significant considerations, especially given the sensitive nature of real-time processing of personal data. Likewise, integrating SeedRealtime into existing frameworks, particularly those built on legacy systems, could pose technical hurdles that might deter some businesses. For developers eager to experiment with SeedRealtime, ByteDance provides an accessible API. This allows for the testing and integration of the model in diverse applications. Conducting side-by-side comparisons with other leading large language models, such as OpenAI's Sora 2 or Google's Veo 3.1, offers a strategic approach to understanding its performance and finding suitable implementation scenarios. Beyond technical proficiency, SeedRealtime represents a cornerstone for future immersive user experiences. As it increasingly becomes a mainstream tool, it could potentially redefine digital interactions in multimedia-rich environments, implicating broader trends in content creation and communication. Its adoption might accelerate AI use in the content creation industry, including gaming and film, while also raising new questions around copyright and ethical use of AI-generated content. Moreover, its capabilities might lower barriers to entry for creating complex multimedia content, potentially revolutionizing how creators and consumers interact within the digital space. The importance of observability platforms in AI development has risen dramatically in 2026, playing a crucial role in the monitoring and enhancement of large language models, LLMs. Platforms like Langfuse, Langsmith, Braintrust, and Aries are leading this charge by providing essential tools that capture AI behaviors, ensuring reliable performance across various applications. Langfuse stands out with its open-source, MIT-licensed framework offering both hosted and self-hosted options, making it a flexible choice for diverse teams. Its visibility tools are designed to provide comprehensive traceability and evaluation workflows, ideal for small to medium-sized enterprises looking to maintain high-quality AI deployments without excessive costs. LangFuse's free tier makes its observability capabilities accessible to many organizations, expanding its reach across different sectors. In contrast, BrainTrust focuses primarily on integration within CI/CD frameworks, offering user-friendly evaluation pipelines that ensure seamless deployment cycles crucial for maintaining continuous integration and deployment CI/CD processes. This alignment with CI/CD is vital for companies striving to maintain high release velocity and consistent performance metrics. Aries caters specifically to enterprise environments, boasting advanced features like role-based access control, RBAC, and cohort analysis capabilities. These tools provide granular access control essential for maintaining compliance with industry standards and enhancing decision-making with detailed insights into AI model performance at scale. Langsmith shines with its zero-config tracing setup, especially beneficial for those already embedded within the LangChain ecosystem. This accelerates integration by reducing setup time significantly, potentially allowing teams to start tracing with less than a 10-minute onboarding process. This efficiency is a major advantage as it minimizes disruption to existing workflows and allows for rapid deployment. However, while these platforms offer numerous benefits, they also present challenges. Complex integrations can arise depending on the existing architecture of an organization's systems, and the varying costs associated with these tools can lead to significant budgetary considerations. The total cost of ownership, including potential hidden expenses, must be carefully evaluated in the decision-making process. For those interested in exploring these observability platforms, practical steps include examining LangFuse's GitHub repository to understand its configuration and setup process. BrainTrust's CI/CD documentation offers insights into its pipeline integration, and viewing Aries' platform demo could provide a deeper understanding of its cohort analysis capabilities. As the landscape evolves, observability platforms are more than just tools. They're pillars of AI integrity and performance. Ensuring robust and seamless AI solutions is not just an option, it's a necessity for AI success. As we see developments like Muse Glimmer and SeedRealtime paving the way for future AI innovations, it's crucial to embrace the tools that ensure the reliability and integrity of these models. Explore, innovate, and let's harness AI's potential responsibly. Until next time, keep coding.